In this lesson, we are going to discuss about chemical energetics. How can we calculate the chemical energy change or the enthalpy change for any chemical reactions? So let's start. We are having the two types of the chemical reactions on the basis of energy. One is the exothermic reaction and the second type is endothermic chemical reaction. Exo means out or exit. So those reactions in which energy is released in the surroundings, they are called as exothermic reactions. The energy is released like in the form of thermal energy, it is released in the surroundings. We call them as an exothermic reaction. Endo means in those reactions in which energy is absorbed from the surroundings, those ones are called as endothermic chemical reactions. So these are the two basic types of the reaction on the basis of absorption and release of the energy. Now think about the combustion reaction, the burning of fuels in which the energy is released in the surroundings. The temperature of the surrounding is increased in the combustion reaction. So this is the sign of the exothermic reaction. In exothermic reaction, the surroundings temperature increase, which we can easily measure using the thermometers. In the same way, think about the photosynthesis reaction. It is dependent upon the sunlight. If the sunlight is not present, photosynthesis won't happen. So in this way, in the photosynthesis, the sunlight energy is absorbed and then the chemical reaction occurs. If the sunlight energy is not present, this reaction cannot occur, means it is the sunlight dependent. Those reactions are called as the endothermic reactions in which energy is absorbed. So when energy is absorbed from the surroundings temperature decreases in the endothermic reactions. So these are the two examples, but if we talk about the temperature change, it is applicable to all of the exothermic reactions in which the temperature of the surrounding is increased and temperature of surrounding is decreased for all of the endothermic chemical reactions. In the same way, if we talk about the bond making process, there are the two elements, sodium and chlorine. They react together in order to form the sodium chloride. The chlorine being used on the reactant side is in the atomic form, although it is existing at the room temperature in the diatomic state. So this is the example of bond making process in which we are using the two reacting particles in the atomic state. There isn't any kind of molecule or combined state on the reactant side. These both are in the form of atoms. They can easily react together and form the product sodium chloride. So it's the pure example of the bond making process. Now whenever this sodium chloride is made, in a result it releases energy in the surroundings because it is now stable. So the stable compound has always less energy than the reactants. So bond, when energy is released, it means bond making process is the exothermic process. In the same way, if we talk about the same product, it can be broken down into the reacting particles in their ionic state, sodium ions and the chloride ions, which then can be converted back into the atomic states. So this is an example of the bond breaking process in which we can see the compound is broken down back into the reactants by which it was made up of. So this is the bond breaking process. Now as we know that sodium and chloride, they are combined together by the ionic bond. In order to separate them, we need to break this bond, and in order to break this bond, energy must be absorbed. So when energy must be absorbed in order to break the bond, so bond breaking is the endothermic process. We will call it as an endothermic process. So for any chemical reaction, if it is the bond making, we will call it as an exothermic process, and if it is the bond breaking, so there is the endothermic process. But now, not all of the chemical reactions are just the bond making and the bond breaking. Let's take an example of preparation of ammonia in which nitrogen molecule reacts with hydrogen molecule and forms ammonia molecule. This 3 and 2 are just for the balancing the equation. Now in this equation, you can clearly see on the left hand side of the equation, we are not having the atomic state particles, we are having the molecules. Like nitrogen N2, it means 2 nitrogen atoms are having the covalent bond. In the same way, there are the 3 moles of the hydrogen molecules. In each hydrogen molecule, 2 hydrogen atoms are bonded with a single covalent bond. If we need to see on the ammonia molecule, there is just 1 nitrogen at the center bonded with the 3 hydrogen atoms, forming the covalent bond with the 3 hydrogen atoms in each molecule of the ammonia. Now in order to form ammonia, first of all, on the left hand side of the equation, there are already the molecules in their bonds are given. We need to break these bonds. The bonds must be broken down so that the nitrogen atoms are separated. When the nitrogen atoms will be free from the bonds, it can react together with hydrogen and forms the ammonia molecules. Otherwise, the reaction cannot occur. So this depends upon the chemical reaction. This is a sort of chemical equation in which we can clearly see on the left hand side of the equation there is the bond breaking required, because the reactants that we are using in this chemical equation are not free, are not in their atomic state, they are in the molecular state. So the bond must be broken down, bonds must be broken down for nitrogen as well as for hydrogen. Let's take an example to break the bond between the nitrogen, we are going to supply the energy of 100 kilojoules. This energy is absorbed by the nitrogen molecule. In the same way, for all of the hydrogen molecules, the bond between when it was broken down, so there was the 300 kilojoules per mole energy required to break their bond. So for all of the 3 moles, it is 300 kilojoules. This energy is also absorbed energy. So overall, if we sum up the total energy absorbed, so the energy absorbed total is equals to the 100 plus 300, it's total 400 kilojoules. So for this particular chemical reaction, 400 kilojoules energy must be absorbed in order to break the bonds between the reactants. Once this amount of energy is given to this reactants, they are free to move, they can easily react together and they can form ammonia molecule. Once the ammonia molecule is made, this is the bond making. When there is the bond making, the energy must be released in order to make the bond compound more stable. So energy must be released in this process. So for example, the energy released in this process is 500 kilojoules for this particular chemical reaction. So we are going to use these values later on when we will calculate the enthalpy change and discuss about it. So this is an example in which there was involving bond breaking on the left hand side of the equation, bond making on the right hand side of the equation. The previous example that we discussed, they were very simple. They were either bond making, either bond breaking. But in the exam, you will be given such scenarios in which there are the both process occurs. In the same way, if we can clearly see on this equation, there is the magnesium reacts with the hydrochloric acid. There is the magnesium chloride and hydrogen. Now magnesium is in the atomic state. It isn't having any bond with like any negative ion. So it do not need any energy to be broken down, but as well as the hydrochloric is concerned, it has the bond existing between hydrogen and chlorine. This bond needs to be broken down, so energy must be absorbed from the surroundings at this site. The magnesium and chlorine, this is a bond made. Bond made is whenever the bond is made between 2 or more than 2 atoms, the energy must be released in the surroundings. Same is the case for hydrogen, the energy will be released in the surroundings. So this is how the chemical energetics works for the chemical equation. Now when we talk about this energy released or the energy absorbed, here is the concept related with this energy released. We call this energy as the enthalpy change. So enthalpy change is denoted by delta H. The symbol of enthalpy change is delta H. Delta means change in the enthalpy. So whenever the chemical reaction occurs in which there is the energy change, like absorption or the release of the energy, there is change in the enthalpy change. So we can calculate simply enthalpy change by energy absorbed minus energy released. Energy absorbed during the chemical reaction, and it is mostly on the left hand side of the equation, the reactant side, minus energy released. It is just the subtraction of these two energy values. You will be having the delta H for the chemical reaction. So for example, there is energy absorbed and energy released for the reaction that we discussed, this one, ammonia molecule. If we can see, the energy absorbed value is 400 kilojoules and the energy release is 500 kilojoules. So let's now use these values, 400 minus 500, 400 minus 500 kilojoules. Normally the values are in the kilojoules per mole. We have already calculated for the number of moles, so we are using just in the kilojoules. 400 kilojoules minus 500 kilojoules. So the answer will be minus 100 kilojoules per mole. So this is the minus sign. What does it mean by that one? We can clearly see minus sign means that there is a more energy released in the surroundings. There is the less energy absorbed, like 400 kilojoules energy is absorbed and 500 kilojoules energy is released. So this means that the reaction in which there is the more energy is absorbed, that is called as the endothermic reaction, and the energy chemical reaction in which more energy is released, that is called as the exothermic reaction. So for this particular reaction, more energy is released, more energy is released, so that's why it is an exothermic reaction. Now when we will define about the exothermic reaction, we won't define in this way that there is a release of energy. We will define completely that the reaction in which the more energy is released than absorbed, that reaction is called as the exothermic reaction. Same is the case related with the endothermic reaction. If we are having the delta H in which the energy like absorbed, it is 500 kilojoules and the energy release is 100 kilojoules. So from this we can easily calculate delta H equals to 500 minus 100, that would be 400 kilojoules. Plus sign is mandatory to mention, minus as well, 400 kilojoules. So this is the endothermic reaction because more energy is absorbed from the surroundings than released. More energy is absorbed, or more energy is absorbed to break the bonds than released. So this reaction is called as an endothermic reaction. So this is all about with the chemical energetics and calculation of the enthalpy changes.